Good morning. My name is Bill Redmond. I'm with the Hastings Cable Access Channel Committee, and we are at TNR Machine in Cedar Creek. We're with Tom Watson. Tom is the owner and president of TNR Machine. Tom has a school here. We're going to be looking at the school a little bit this morning. He provides us for training for students. He has 4 students. He'll have 3 up here today, and we'll be talking with those gentlemen a little later. Tom, when did TNR start?
We officially started in '87.
87. Who started TNR?
I did.
You did?
Yep.
Okay. How many students do you have today?
We have 4 altogether. We have 3 here today. So
3 here today. And what does their schooling consist of?
Our schooling is actually a dual enrollment high school program, which is tied to KCC. So they're going through a machining course. So they'll start from basic hand machinery, laying out things, to the final thing after they can go as a junior or a senior. And after their junior year and they go through their senior year, they can go into the CNC side of things. So they go from manual all the way through CNC. Very
good. And where does your students come from?
Right now, most of them are from the Hastings area, but we do Hastings, we do Delton, Berry County Christian, and we've now tied up with Thornapple Kellogg and Middleville. So.
Very good. Okay, what's the purpose of the school, Tom?
My sole intent was to address the skilled labor shortage for our local area so that our local businesses would have skilled labor coming up for the future generation of people that are retiring.
And these students, they pay nothing for the school, correct?
Nope, it's part of the dual enrollment program, which the state pays for them to take the college course.
Okay. How long has the school been operational?
Our first year was 2016.
2016, so you've been running, this is your 3rd year?
Yep, this is our 3rd year in.
How have you enjoyed it?
Awesome, it's a learning experience for myself and the students, I guess.
And how, other than your students and yourself, do you have any other people that's involved in the school?
As far as?
Helpers that come in to help you with the school or anything?
The very first year, I had 2 teachers that helped me the first year. And then one with some health issues, he couldn't do it. So then I took over myself. So
you and the students?
Yep, just me and the students.
Got to be a good cooperation there. How long is classes each day?
Classes run from 7 till 9:30 every day, 5 days a week.
5 days a week. Okay. How many classes do you have in a school year?
We have 1 class in the morning right now. And as we build, my goal is to get to 20 students. When we do that, we're going to run a morning class and an afternoon class.
And it runs the school year,
The full
right?
school year, yep, okay. From September to May.
Okay. Is there any charge for the school?
Nope. All the costs are covered either by the state or outside sponsors I have.
Okay. And you have, tell me again where the students come from?
The first year we had about a 50-50 at Delton and Hastings. This year we're more Hastings related. Last year we had Berry County Christian, Hastings, and Delton. So we're getting a pretty good mix. Just needs some more lobbying in the schools to get more kids to.
And you said that you have Middleville.
Yes. Yep.
Maple Valley, are they involved yet?
Maple Valley is involved, but right now we're trying to get all the kids that are just closer to my side of the thing so they don't have the drive time problems.
Good, good. What is the school involved? What is this young man here? What is he doing?
He's actually running a manual lathe. He's actually working on a project to make himself his own tap handle. So they start out right from the very beginning, from learning to lay things out by hand to being able to run the lathe and make all their own parts.
Good.
And all the parts these kids are making too are parts that they will, when they leave here, they will have tools for if they go into the trade.
They take them with them.
Yep.
There's a coat rack over there that the students made the first year. That is, the pegs are aluminum, the bar is aluminum, and the students made that. That was their first project for the school. Tom is pretty proud of the students, I think.
Absolutely. Yeah, so now this one here being left-handed threads, go down to your line. So now as you go down, yep. So now we're going to start this time. You're starting here, and now you're going to feed into when it's running.
Okay.
And then when you turn this handle on, now it's going this way.
Instead of going that way?
Yep.
Okay.
So now when you start it up, with it being left-handed, we're starting here. So now every time you're going to come back to your 0, now you're feeding into it when it sets there, and then you're watching for that number to come around, and you're going again.
Okay.
before you do that, we need to slide that out. Put it out on your center so it doesn't run out so bad for us. We want to slide that out to our center. So that, yeah, we're going to want to bring this out to the, here, we're going to bring this back out so we can slide your part out. So we thread out here by the end.
Want this out more then?
Yep, you're going to stick it all the way out, just like we did yesterday. So when you get this out, lightly snug it down. So now when you're here, no, tighten it down too much yet. Put our grease in there. So now from there, we'll work on it going the opposite direction. Coming out. There you go. Good. Yep. There. So now when we go to here, we'll get that close. Now loosen that up. Then you're going to slide this out to your piece now. There. Now tighten it down. There. Now when we set up our, now as we set up to run our part, now we're running it from there going this way. Okay. So now let's go back over and eyeball your line because you can go to the same number and just set yourself as there. You don't have to go off the end. Yep, come to your line. Now you can set 0 from there. It's going to be easier than going the other way anyway, because you're going to go to that same spot every single time and come back. So now you can just set your dial down here to 0. Yep, and touching, close. There you go. And I'll set your bottom dial at 0 so you know where to come back to. Okay. Perfect. All right, so now you're going to do just like that. We're starting her up. Okay, now you're going to run in your 5 thou. Actually go until it touches, actually. Go until you see it make chips. Keep going. Keep going. Right there, set that dial back at 0. Perfect. Yep, so now you got to watch that number come around going the other direction. Now we can
get out of line still.
Make sure it goes on number 1, yep.
Okay.
And now this time we're threading out into the open, so there you go. So now it's threading going the other direction. Now when it comes off the part, now you can stop it, back it out. There you go, good. Yep, you're backing out like you did yesterday. There you go. Now you're going back down to your 0.
Okay.
There you go. Now you're going into your 10 thou. And you're waiting for your next number to come around.
There you go.
Yep. Perfect.
Then once you get up to 30, do 2 at a time?
Yep. Once you get to 30, you do just like you did yesterday. We'll go 2 at a time.
Okay.
And now you're not so fast on making sure you hit the shoulder now.
Okay.
Yep. Make sure you get your number back in. It's a little easier to work than yesterday.
Yeah.
Now now you can see the numbers coming from the other way. Mm-hmm. Make sure you're hitting on a 2. Don't. You can probably almost use the 2 most of the time around, but not. Yep, looking really good. Now you're making the opposite hand now so that when you spin the handles the same direction, it tightens things up. Yep, similar to a wood clamp one. They had the option of making both of them go the same way, or right hand and left hand. Well, I made them do the left-handed one so they had a little bit out of their element on the second side. Yep.
Expand their living a little bit.
Yes, that got a lot, makes it a little tougher to do, but actually they learn that it's easy when they're all done. Yeah, I've implemented most all the projects we do now are something retired or related to them being able to take them and use them in the industry when they're done.
Absolutely.
Where some of the projects that KCC is a little different setup than I am because I'm more one-on-one with everybody. Down there they have projects, you know, that they're making a block of steel when they're all done. It doesn't necessarily mean anything.
Yeah.
Well, I made it so everything we build is something that they will be able to take with them. So
Probably use it for years and years.
yes, actually the one we were copying is from one of our tool makers up top. His grandpa made it in 1940. So
My son has my machiner's toolbox.
yep.
That was originally bought in 1946. I'm at 30 something, 2 at a time.
Yeah, you start doing two thou at a time instead of 5 thou. Yep. And what did we end up on yesterday? Roughly 50 something?
It was 62.
Oh, yep. So we'll be close to that again, depending how much you touched it when you did it this time. So now it'll be maybe a little bit different, but it'll be close to it.
Would that have been good or no?
No, it'll not. It'll jump threads if you miss that number. If we miss a number, just
Is
make.
that good or no?
Oh, that was fine.
Okay.
It'll start going an opposite thread up there, so it'll start missing its thread if it's off. Yep, wait for the next one. Yep, don't try to hurry. If you miss it, it'll cross thread those threads.
Okay.
Yep, so obviously here we're doing a little teaching on this one here. Yesterday we taught him how to make a hex on a part for putting a wrench on there to be able to make a tool we're making. Today he's building a square to put a wrench for our chuck for our lathe for our backup one. So he's learning to index the part to get a size that we want. Matt's a first year student. He started in September with no machining knowledge whatsoever, and maybe we'll get a chance to look at. We have some parts that he's made that being first year, it's impressive when as you start going, is what they can actually do in a short amount of time. Getting close. Technology, using the phone for not social media and calculating now. So a little bit more on the thing. The students are running a lathe over there, making the parts over there. They were over here the last 2 weeks building parts to go with the plant pieces. So we kind of run them in pairs, try to.
Kind of like a sequence you're going through.
Yep, so they start out with the mill. When they are done with that project, he's going to do the same one. So then we'll rotate from him being on the mill to them guys being on the mill and finishing up their part of the project. So it's definitely rewarding to see the results they get from nothing to, 5 months in, they can do a lot more than you thought they could.
Wow. Where does your machines come from, Tom?
Actually, all of our machines we purchased through Elro Steel, actually.
Elro, okay.
Yep, they actually gave us a pretty good discount buying all of our machinery through them. How much you got to go?
60, so probably 30.
How much?
About 60 thou.
60 thou.
So only 30.
Yep, you gotta take 30 off there. And then you have to come out the end too and get the end when you fall off at the end. Yeah, and this part of the project is teaching them how to index. Trying to get to know how to make the part square or hex or whatever we're trying to make that day. Yep, then once you're all done with that right there, then just slide out to the end and go across there and pick the end of that off. That had been last week. We did some work for the Hastings robotic class for their robot. They were missing some axle shafts, so they sent the parts out for us to
Duplicate.
Yep. So try to, on the robotic program, they've got a budget they got to stay within. So if they farm parts out, they have to add that cost into the robotic program, so they only get to spend so much. But if we use the Hastings students to build their parts, it's free to them.
It's free to them.
Yep. So now with the shop down here, they can send them down and have the students build the parts, and then it makes their budget that much easier to work with.
It helps their budget, plus it helps kids.
Yep. So. Make sure this one here on plant too. Okay. Yep, back her up a ways. Keep going. Keep going. Keep going. Yeah, you can move right out there. There you go. That'll get the end off there that way. Yep. Just snug your table back down and careful, don't put your hand in there without running. Yeah, the other thing is kind of challenging sometimes is get the kids to understand the safety side of things.
Safety of it, yeah.
Yes, it's
Yeah.
you know, obviously at that age, you are a lot more fearless.
Yeah.
You think,
Yeah.
so. But they learn.
Okay. Yeah.
You try to educate them the best you can, and
Well, you're doing a good job, Tom. I'll tell you that.
it's definitely satisfying when you see where kids come from and where they go to, and by the end of the school year, the amount of things that they can do are really impressive.
I can imagine it's very satisfying.
All three, two out of the three students that are down here today, have never run a machine before they ever get in here. So to see them making parts, through the school year is really impressive.
Oh, I bet.
How big do you have to be when we're done?
386.
There you go. Right down the money that way. How's the other way? I'll check another way. Yeah, your mic's not square. There you go. There you go. Nice. Very nice. Now I'll take that one out and then we'll file all the corners, make sure all these edges aren't sharp. What's that? You gotta go back and get the shoulder yet too?
Wasn't in the back all the way.
Oh, so you got to make the finish pass now? How much we got to go to? Right there? Half-inch back? Yep, careful going across there. Yep. That'll be our last pass to hold our shoulder. Good. We even did a few projects last year that we did that were farm projects. Had a couple local farmers bring some parts in, and they donated money back to the program rather than.
Really?
Yep. So.
That helps everybody.
Yep. They bought the steel, they bought all the stuff, and then labor, and then they donated money back in for us. We actually got to buy some new tooling from that last year. Yeah, the kids got to see what it is to work on farm equipment when it's already in rough shape. So that should put us on the final pass then?
Sure.
Got all four?
We're now in the main part of TNR machine. This is the production area. Tom has
40, we have 42 people right now, actually.
42 people that are employed here. We have CNC, most of these are CNC machines up here.
Yep, we only have actually 2 manual machines up here, so everything's automated up here.
Okay. We're going to show some of the operation, watch a couple of things that the employees are doing, and Tom can explain them as we go and tell what the people are doing.
First, we'll work on everything there. We have Sarah here is actually running one of our 5-axis machines, which is new to us the last few years, trying to get in the world of technology. She's building some parts that are for Denso Manufacturing, which is one of our biggest customers. Here, what this allows us to do is do a lot more sides without having to reset up every time. So just making it easier for us to do harder projects easier. So
Work smarter, not harder.
yeah, absolutely. Yep. So this is one of our latest machines we bought as far as technology, trying to get us up into the upper part of the new technology in here. So she's new to the 5-axis. She's like her 3rd week in, so she's taking a different challenge on the machining world. So
Good for her.
Yeah,
How do you like it?
I like it a lot. It's a lot more challenging, but a lot rewarding too.
obviously we have to go to do our CAD part of the department. So going into this area now, this is more on our higher end of our finishing part of the thing. This is our wire EDM department. So pretty much everything we do that is tied to the die and mold industry all ends up coming through this part. The wire side of things is a lot more precision and a lot more delicate pieces we put in through here. Our latest machine is a little bigger, made a bigger envelope in it so we can run more parts without having to be manned, so get more unattended burning. So the advantage of this right here is the amount of accuracy you can run on here on delicate parts. So this one here that runs at least 20 hours a day on the average of overnight burning and stuff we get out of it. So it allows us to get hands-free.
How does that machine work, Tom?
Well, this one here, the part is grounded. The upper head has a brass 10 thousandths diameter wire, and all it does is has a controlled arc, and it burns the material away. This one here, you can actually see the actual arc down inside of there where it's actually burning material on this one. Yeah, what we do on this one here, right now we got a project that we developed and helped troubleshoot for Denso. It's called a flying cutter. There's a pair of these cutters, they run together. It cuts off a 39-inch tube, one every 2 seconds. With it not moving, it never stops. The material's always moving, and it keeps cutting it moving. So this is actually sliding back and forth and cutting it off. So we spent 2 years trying to help them develop it so that it can run faster. So now they can do twice as many parts in the same amount of time. So
I've been around this for most of my life and it's still interesting.
yes, it is. The amount of change is amazing.
Yeah, oh yeah.
Always a new challenge.
Every day.
Yep.
Every day.
Yeah, the downside of this one here is with our development of changing how they did the part, and then it cost us about $100,000 a year in revenue, being the fact that they use half as many parts now, but we generated more income on a different part of their business, so it, in the long run, helped us out.
Now what are these, Tom?
Those are what they call fin forming rolls. They make the tubes that go in your radiator that the water flows through. Yep, it's part of there is, I think, 25 rollers in every machine. And it starts out with a flat piece of stock, and by the time it's done, it folds it all the way around and turns it into a oval tube.
Roll former.
Yep. Here is where all of our stuff actually starts. All of our stuff starts in our CAD CAM side of things. As you can see here, we program everything offline here, and then from there goes out to the machines. In here we can do simulated stuff, so we know what everything's going to look like before we machine it, where things are. So everything that we do in here, we try to do up front, so that we allow us to, when we get on the shop floor, our machinists have an idea where everything's at, allow them to be a little more efficient on the floor rather than a lot of shops still program and do all their stuff on the floor. We try to do offline so we can have more uptime for our machinery.
Makes it more efficient for the operator, that's for sure.
Yes.
A lot of the work's already done, time it gets to them.
Yes. Yep. Puts a little more responsibility on the programmer, but allows us to have some more spindle time.
But if they make a mistake here, they can correct it without ruining a machine too.
Yep. Yep. The software has gotten better to where you can detect a lot more stuff in here.
Yep.
Yeah, that's a continuous process in here for us to looking for new people to come in and help program too. Trying to seem to be always short-staffed in here.
Do you have a hard time finding people?
Yes, we do.
Yeah, everybody does.
Yep, and that's obviously the biggest side of trying to get the school up and going and trying to get the skilled kids to come up here. We've had we got three. We had 3 kids from down below have made it up to here, and all of the kids that have made it through there have gotten jobs in the industry. So we're 100% on, yeah, we're 100% on getting kids into the system, but just need more.
I congratulate you.
Yep, so most of this stuff here is on the mill side, and we also do the exact same thing on our lathe side of it as we do on the mill. We have our programmer having things done prior to making to the shop floor. The advancement in technology on the CAD side has been huge for us. It allows us to be a lot more competitive and learn new things. as we go around, we got our new machine out there is our live tooling, which has got mill and lathe on the same machine. So that's got a new challenge on our programmers in here too to add to that problem. All right, and also on our inspection side, as everything we do comes through here at the end before it goes out the door, so that everything has been inspected, so that we know that our customer is getting the quality part that they deserve. And I'm Bill. I don't know if you've met Ron, which is my brother, which is our partner. He's been in it since the beginning with us. So it's him, myself, and my dad are in the business together. And on our new inspection department in here, when we moved to our new building in 2013, we had 18 people, and now we have the 42 people. So we put on a chunk of people since we moved to the new building. So we upgraded people.
Well, it shows.
We've invested a lot of time and effort in trying to get technology up, and then on top of that, well, I guess one of the things that's a hindrance and a good is I think we have 16 of our employees that are under the 28-year age group. So we've got a pretty young group going through.
All that's going to do is make it better in the years to come, though.
Yeah, so
Yep.
the amount of guys that are in the late 50s, early 60s wanting to retire, there's not much behind them. So hopefully we can jump on that train and we'll be ahead of the game. But it is a slow process getting the younger generation trained to being skilled enough to do the work we want them to do. So
You put a lot of time and money into the future, and that's you're to be commended, both of you, for that.
thank you. Yeah, the future is definitely the younger generation's got to cover us. So.
Oh, absolutely.
Yeah. When we're running into our grinding department, which we've tried to keep up with technology, we've invested in a CNC surface grinder to be competitive on the automated side of the world. Our next purchase is our new. We bought a new OD grinder. It is only one of 3 that is in the country, and we have the only one of this model. So we have a $500,000 investment into a machine that this is the only one in the country right now. The technology is new. It's got capabilities to grind round parts as well as grind parts that have a cam on them, and it also can grind threads. So the technology on this machine is brand new. The controller on it's the first one generation out. The even comes with LED lights telling you when it's not running, green when it's running, red when it's got an alarm or it's stopped for a problem. The advantage that this machine here ends up having for us, it has 3 wheels. It's got 2 OD wheels, an ID wheel, and a probe to touch off the parts, so we can do all the setups in one shop. So we can do like a part like this right here. The grinding wheel can bump here, it can grind here, and then the head can actually turn and comes over here, can grind on an angle. So we can now do all those without ever having to let go of the part. Which before over here we had to stop it, we had to turn the part, we had to do all kinds of things to get the angle. For this one now it doesn't have to do that.
Now, is he making this part here?
Nope, he's making a similar part to the rollers we have in there.
Oh, okay.
Oh, sorry, Rich. So the biggest advantage we have of this one here is, we can actually grind the inside and the outside and all that without ever letting go of the part now, because the ID wheel is tied right to it. Can you back that up and spin that head around, please? Which now allows us to be able to bring whatever head we want around there, whether we're grinding straight, grinding angled. So we pick what we want to do. We can pick the wheel we want, spin around the one we want to. Yeah, the LED lights on the end was an option to and they threw it in as a thing when we bought the new machine. We bought it at the tool show, and being that we bought it at the show, they threw the LED lights and some other features on it.
It's in Chicago.
Yep. Yep. Yeah.
Farming Center.
Yep. Yeah, we've been looking for like 2 years trying to find the one we want, and this has come out. It's brand new. So they had one at the tool show that showed up 2 days before the show, and that was the only one they had. And then we end up getting this one here right before Christmas. So it took them 2 months to get this to this one.
So is this last Christmas? Or
Yeah, just. So
it's only been here a couple, 3 weeks.
Yep, it's been here. Right, we actually installed the first week of January. So this is not quite 2 months. So yeah, the controller's new. What they did is the Hardings group, they own 4 different grinder places. They took all the things that everybody liked and put them all on one machine. So
Where was the machine made at? Germany?
Switzerland.
Switzerland.
Yep. Swiss made.
Like a watch.
Yep. This one here is actually running some more parts to make the fins for the automotive industry, for the fins for your radiator. This makes the fin. This separates them out. This one also has got, as you can see, the coolant in here is clear, brand new. The coolant's brand new. That's come out. It's been out about 6 months. It's a full synthetic. So you can put your hands in it. You can put all the stuff in there. No problems with any of that stuff. And it's clear the whole time. So the advantage of, as you can see, some of the other machines, it's oil-based. This is not oil-based.
What's going on in it?
Yep, this one's all synthetic. This one here is making which spaces the fins out, so that other cutter I showed you earlier can cut the parts off. So what it does is it spaces them out like they're like an accordion. It spaces them out, cuts them the right length, and then when it comes back, so that when they assemble it, it's the right length. So that
Technology is
Yep, so this one here we're using, obviously using,
every day.
yep, we have to use the 4th axis on this side, where the first machine was our 5 axis. So this one here we can use our 4th axis, so it's actually spinning the part and moving at the same time. So yeah, on this side of it here is our EDM side of this one here. This one here actually makes the end tubes that are on the end of the condenser unit. This is actually the punch that punches the end of those on there. So when they assemble them to solder the tubes on, this makes the end caps. So it's got a top profile on them. That's the shape of your condenser. Nothing.
Like I said, I've been around this stuff all my life. It still blows my mind.
Yeah, the amount of things you can do today is really impressive. The sinkers still haven't quite made it up to the speed of everything else in the world, but the things you can do with it are still, a necessity to us. There's some area you just can't. Like that part right there has so small of a corner in it that you can't wire it or anything. It's got a 4/1000 undercut in it. Yeah, so like where you're seeing it was just sinking, it's sinking this corner out here, which is a 4/1000 corner in there. And it's actually backdrafted, so you can't come straight through. So it's diagonal to the middle, so that corner, so when they punch it out, it leaves a sharp edge there, so they don't have to re-deburr the part. So that corner is so small, and it's blind, you can't go through, because it has a piece in the middle. So you end up having to sink it up.
How many of these do you make a year?
We do about 100 of those a year, so depending on how much they crash.
Yeah.
If they crash, they use 20 at a time, yep, but usually about 100 a year. They last about 30 million hits, each one. So, yeah, so the necessity for the sinker is big on this one.
What kind of steel is that?
M2. Yep. Yeah,
Is all of this done on that machine?
between this machine and wire machines.
The wire machine.
Yep. The wire machine does all the top contour. Then this does all the side contour in the back.
Incredible.
Yep. So, yeah, every one of the condenser units, this is cutting the end cap, and they actually stack when they run them. They're stacked, down through the die like that right there.
There's 20 of them in a row.
Yep. And it's actually working its way down it. So this one here is upgraded to newer technology also. This one here is got it laid with live tooling in it. So what we do now, where in the past, you had to turn the part, and then from there you'd have to put it in the mill to put all the holes in. This has all those tools in there. So now we can actually turn the part, we can drill all the holes, and then we just cut the part off, so then the part's done coming off one machine.
Multi-head.
What's that?
Multi-head.
Yep. So we got live tooling, and it can either drill holes going sideways, it can end mill, and also can drill on the edge of the part too. We can have tools coming out this way also. So it allows us to, instead of having to take it off one machine, put it on another machine, and put the holes in, we can completely run the part on here, and when it's done, the part's done. Yep. So this one, allows us to do multiple features on without ever having to let go of it.
Time saver.
Yep. So this is our newest investment. Try to always keep up with what technology is doing, allow you to free up some time and effort in this. These parts here now, which is kind of interesting on the thing there, these are for Die Castle in Greenville, Michigan. They build aluminum rims at 10,000 a day. So we do a lot of the tooling for holding on to their part, and we do a lot of gauging for gauging all the truck rims and all the stuff for the bolt patterns, all that stuff. We do a lot of that. And this customer came from, he used to work at Musashi Auto Parts in Battle Creek and lived in Rockford and didn't want to drive anymore. So he went to Greenville. So when he went to Greenville, he took us with him. So it's the customer relations, by keeping somebody happy as a customer. When he moved, the work went with him. So,
The other way it happened.
yep. And all of our business is all word of mouth. We don't have a salesman or nothing. I did one sales call the first week I went in business. That was it. That was 1991 full time. Never had another salesperson ever. So.
Well, by the looks of things, you don't need
No, we struggle to keep up as it is. So, yeah, that's where the school and the younger generation's going to come back to try to help us in the end. Us and our local businesses should be able to profit highly from the new skilled labor. Yep.
Everybody's going to profit.
So, yeah, then like here versus here, this one here, you're still back at the old school side of things. Just the old-fashioned lathe. So we go from this to the new live tooling one. It adds another dimension. Talking about the younger generation here. We're in the 20-year range here. He's been just over a year on learning to run. So start out for us doing odds and ends and worked his way into machining.
Well, that's where our future's at.
Yep. So allows us
That's
to.
where the future's at.
Here we're into our milling department. On one side we have a younger, newer employee doing some hard machining on some forming dies for Denso. Then we have on this side over here doing our fixturing stuff for Denso. So trying to teach them the new ways of doing things. And, part of being on thing, our next generation, this is my youngest son, they're teaching him on the machining side of things. So try to keep in the family side of things going. But teaching him how to machine has been a interesting couple of years. He's done really, really well.
Good. This is the end of our tour. We want to thank you very much for this, and we hope that the listening audience will get something out of this also. What inspired you to start something like the school?
Well, with a shortage of people we had up here, we're lacking the skilled labor, and then going back to when I was in high school, and somebody gave me the opportunity to get a career that I've had for 35 years, and it's done well. I figured it was only fitting to give back to the younger generation and to get an opportunity like I had. So the goal was to allow students to have an opportunity. Being that Hastings High School took away, and Delton, all them guys took away their machine shops, I figured I would help that situation out and give back. So,
How long have you had the school going?
it's been going full-time since 2016.
2016.
Yep.
And you've had, your goal is to get 20 students per year.
Yep, get 20 students per year to push into the industry. So
you're going to have a full-time job just down there teaching students.
yes, yep. Actually, I've had some people who are interested in teaching once we get up to where we can full-time. If as long as we're teaching the curriculum at KCC, part of the agreement we got with them is that they will pay for the teacher. So they pay for the teacher once we get to that position. So.
Well, I appreciate what you're doing. I hope that everybody else does too.
Great, I appreciate you.
much, sir.
Yep, thank you.
You have anything to add?
Well, it's a huge issue in the manufacturing world trying to get younger students in there. So trying to get the general public to understand that manufacturing is never going away. And that we're going to need people in all facets of the skilled labor side is a huge importance to me. And I'm going to try my best to put more students and more effort into that part of it.
Well, I think the manufacturing world out there is finding out that they need people like you. They need these schools
Yes,
because our high schools aren't making the grade in
nope.
these types of areas.
I can say both all the local high schools now have put in a lot more effort in the last year to really help me out. So I can't complain about them as far as willing to help now. Now it's just a matter of pushing it in front of the parents and the students to allow them to see that there's opportunities out there.
Well, thank you very much.
Great, thank you. I appreciate it.